Welcome into another episode of Automotive Insiders. I'm your host, Jason Stein. Great to have you back with us, exploring the technology, strategies, and people who are shaping the future of the industry. In today's episode, we dive into an area of the vehicle that doesn't always get the same attention as batteries, propulsion, or connectivity, but it's just as critical: the chassis. As the industry embraces software-defined vehicles, the foundation of vehicle motion control is being reimagined. ZF calls this transformation Chassis 2.0, and it's a shift from traditional mechanical components to intelligent software-managed systems, from steering and braking to suspension. It's unlocking new levels of safety, performance, efficiency, and customer value. Joining me to discuss this evolution is Ramiro Gutierrez, president of ZF North America, who explains how innovations like steer-by-wire and brake-by-wire are moving from concept to mainstream, what this means for automakers and their customers, and why the chassis may hold the key to unlocking the full potential for tomorrow's vehicles. It's all about what's changing at the chassis level and how it affects suppliers. That conversation coming up next on Automotive Insiders. It's great to have you on the program, Ramiro. Thank you for joining me.
Hi, Jason. Very glad to be here.
I want to set the stage and introduce the idea of Chassis 2.0 and really how vehicle motion control is evolving in an area that we've talked about on this program before, the emergence of software-defined vehicles. And I want to frame ZF's role as a leader in these innovations. Let's start off with you describing Chassis 2.0. What is it exactly?
Well, Chassis 2.0 is the evolution of the traditional chassis components. And when we talk chassis components, we need to think about the braking, the steering, the suspension elements into the vehicle, and how those elements are adapting to the new electrical architectures, the adaptation of the software-defined vehicles, and how basically those traditionally mechanical components are now becoming smart actuators, where we have a mechanical part of it, hardware, if you want to call it that way, and then how the hardware is now being managed by software and how that works together, not only as an independent element, let's say the braking, but also as a system influencing the vehicle dynamics and creating value for the end customer. So
and
we go, yeah, go ahead.
No, please.
So basically is what we call by-wire, right? Now you have what it was before, let's say a caliper. Now that caliper is working with a electric motor instead of a brake fluid, a hydraulic system, and that brake motor is connected with a wire to a computer, a controller that basically through software is activating that caliper. There is no more brake fluid, which is a huge advantage for our customers and for the public in general. And then it gives you the ability to activate independent the four calipers of the car and basically be able to eliminate, for example, the caliper drag or the brake pads drag, which influences greatly fuel economy. That is one advantage. Similar thing with the steering. Now you don't have a connection, a mechanical connection between your steering wheel and your front axle. Now you have a wire connection between the two. And then safety aspect, for example, now you don't need to worry about this intrusion of the steering column into the occupant during a crash. So basically you have an advantage in you don't need to go through the firewall of the car driving a steering column. Then obviously from the functionality, now you have a never adapting steering system to whatever you're doing at a given time into the vehicle, from parking to driving on the highway to driving on a curvy road to driving off-road. You have a never-ending adaptation of that steering feel to the necessity of the driver.
How are you, just speaking of X-by-wire, either steer-by-wire, brake-by-wire, how are you evolving to a point where this has become or will become more commonplace in vehicles going forward? In other words, how much advancement has been made? We've been hearing about these technologies for a long time, but it sounds to me like you're making legitimate progress in making this more the norm than the exception.
Correct. This is going mainstream, not only in the future, but we've been first to market in Asia, first to market in North America. And we are obviously having multiple development programs in Europe, North America, and Asia. So steer-by-wire is here and is here to stay, and it's going to go mainstream in the future because there is so many advantages to it. When it comes to brake-by-wire, we're going to be launching in North America on a full-size truck in 27, and we have a lot of traction in the other markets as well to be a mainstream technology element. So it has come to a point where we have a lot of demand for these systems because the customers see the advantage. Obviously, there are changes on the customer side as well in the way they are organized to basically take advantage of the full capability of this new by-wire environment and create value for the end customer. So I think we are only, to be honest, I think we only scratching the surface of what value can be created by the end customer, because you would be able to get software engineers developing functionality that we cannot even imagine right now when they have the ability to combine the longitudinal, lateral, and vertical movement of the car, so the complete vehicle dynamics, and then get that communicated with your propulsion system, get that communicated with your infotainment system, and then the possibility of value creation is, I would say, endless.
As we think about the future of vehicle technology and the future of transportation, I'm going to assume that electronically controlled brakes and steering systems are only going to play a larger role in the development of a future product. I'm sure you don't disagree.
I completely agree. As I say, the value creation for the end customer is key here. Then the ability that our own customers, the OEMs, would have to get into faster, easier, more focus on the value creation development versus the validation of each of the single components. I can give you an example. Our software that we name it chassis basically is able to combine that vertical, longitudinal, and lateral movement of the car, so the steering, the braking, and the suspension of the car, with that software that we call chassis. And that software is not only going to be able to develop functionality, but also going to help our OEM customers, the engineering departments of our OEMs, to tune that vehicle, to validate that vehicle in a much faster and simpler way than going into each of those subsystems, call it braking, call it the steering, call it suspension, independently, and trying to put all them together backwards. So the simulation tools, the development tools that the software can provide to them are going to accelerate. So, you know, in this business, it's all about speed and it's all about cost. And I think we hit in both elements with this solution.
How about customers? How do customers perceive the approach, and is it in demand, or will there be an educational component that needs to be transferred?
Well, I think the customers visualize clearly the advantages of the systems. I think they need to go through the, let me put it this way. It's different when you have, let's say, a new customer, let's say, without saying names, a new electric vehicle customer that is not a traditional OEM. that have a more fluid dynamics in terms of their own organization and how people work together than talking to a well-established 100-year-old company that have certain silos that are more difficult to break. The first ones, they grasp the idea immediately. Then they need to understand how those cost elements offset, because in some cases you would see that a specific component may be more expensive than a traditional component. I give you an example. A caliper with those electric motors inside, right, is going to be more expensive by itself, material-wise, than a traditional caliper. But at the system level is where the cost savings can be realized, not to mention the value creation that has obviously a return for them. So I think the cost element is a factor that our customers are digesting and trying to understand at the system level where the savings are. I can tell you we have a customer that is going that direction, that is creating or building up a new facility, and they cannot be more happy with the fact that they don't need to take care of brake fluid management into the facility with the environmental topics and the CapEx associated to it. So there are multiple advantages, and in some cases are more difficult to figure them out. But I mean, the system has very clear advantages both on speed and speed, value creation, and overall affordability or overall cost.
Final two things. You mentioned an example of a vehicle that's coming within a short period of time in the truck segment. Can you share the OEM?
I cannot share the OEM, but it's a traditional OEM with best-selling heavy-duty pickup truck, and we're going initially with a hybrid system. So the rear brakes are going to be by wire, and the front brakes are going to be traditional. That is a step into the technology, but some of the other customers are going straight with four-wheel brake-by-wire.
Great. Final thing, what's the key to success of Chassis 2.0?
I think the key to success, I revert back again to this value creation, right? One of the things that we're doing is we offer the hardware, we offer the software. The software can be agnostic to the hardware. We can offer the full system, we can offer part of the system, and then on top of that, we open up our software for the end customer to be able to build functionality on top of that software to basically drive, if you will, their brand DNA into their own customers. So we open up the platform both from the hardware agnostic to the building up on top of our software. You can call it a middleware, where you can build upon that middleware your end customer functionality and get your software developers figuring out functionality out of that system that would bring customers through the dealership door, right, buying your vehicles. So that flexibility and that collaboration is key to it. And we are opening it up for collaboration, and that's why customers are entering into this dynamic. And that is, collaboration is fundamental to the success of this.
As ZF says, much has been written about the transformation of the automotive industry with terms such as software-driven and electric mobility. But the one word that is rarely mentioned is the chassis, and that's what you're working on. Thank you for explaining the pathway here and what the future will look like. Ramiro, it's been great to have you as a guest. Thank you.
Thank you, Jason. Thank you for having me.
That's this episode of Automotive Insiders. Thanks again to my guest, Ramiro Gutierrez, ZF Group President, North America. Come back to this platform for more interviews, and don't forget to check out our YouTube channel for interviews done by video. I'm your host, Jason Stein. Thanks again. We'll see you next time.